Hello, am I audible? If am I audible, so please write. Yes, good evening everyone. Am I audible? Hello Kishore. Yes, please, am I audible? Jai Hind, dear, Jai Hind. Oh, great. Thank you. Thank you so much, dear. Okay, so let's start the second session. Okay. So, firstly, revise that we are going for the second lecture of the analog fundamental. So, firstly, introduce that what we cover in the last class. So in the last class we discussed about the network and circuit. So what is the difference between network and circuit? That circuit you can design, or network you can design by the electrical components like resistor, capacitor, inductor, diode, anything you can design. But if they are connected with the supply and ground, means you have a VDD and VSS, that current can flow, that you can say that that is a circuit, means that have a closed path. But if you talk about that the circuit does not have a VDD or VSS, that does not follow that closed path, that is called network. So we can say that network can be anything, can be designed, but the circuit must have a closed path. So that is the difference between network and circuit. And then we discuss about the resistor, capacitor, inductor, and we discuss the effect. Last class we find some doubts like routing. What is the meaning of routing? So I am giving one very basic example of the routing, that is our body. So in our body we have a blood vessels. So in a blood vessel the blood is flowing in our body. So that is the best example of the routing. Similarly in analog circuit we are using a routing in terms of metal for connecting from one point to another point for flowing the current. So you can think in this way, the best routing in the world that is done by the God or nature or energy, that is a blood vessels. Okay, and we follow that. We are trying to make a good routing so that our circuit will be good. Then we have a one more doubt, that is MOSFET and FinFET. Why we are talking about why we are not going for FinFET? Why we are working on a MOSFET? So FinFET is a low level technology. If you are talking about digital switching, high speed of switching, if you want that low power dissipation, you go for FinFET. FinFET is good for digital devices, digital circuit designing. But if you talk about the analog circuit, in an analog circuit, it is good as a MOSFET. Why? Because in a FinFET, you will find that high parasitic capacitance. You will find that there is no any good gain. There is no any high input impedance. In a MOSFET, you have a high input impedance. You have a low power, low parasitic capacitance or parasitic circuits. Okay, so that's why MOSFET is very good for analog, not FinFET, TFET, and GFET is good for that. Till now, they are not good for analog. They are not that much good for analog. So that's why we are working on a MOSFET only for analog circuit design. If you are interested in analog circuit design, we will talk about the channel length. So when we talk about the MOSFET have a channel length. If you have a higher channel length, then you will find the less short channel effect. That is called channel length modulation, velocity, saturation, DIBL, GIDL. That is lot of second order effect you will face if you are reducing the channel length. So in an analog circuit design, many companies, that is Texas and Synopsys, Intel, they all are using 180 nanometer, 90 nanometer, 45 nanometer technology for designing an analog circuit. That's why we are understanding MOSFET till now, and I think it will be continued to 10 years. Next 10 years. Okay. So let's start that first session, the second session of that. So here I am going more deeper in resistor, capacitor, inductor in analog domain. So I am writing one question for you. If we need a resistor inside a chip, what will we do? If we need a resistor inside a chip, what will we do? Can we design a fixed resistance like we have a resistor we use a 5K, 10K, something like this? Or we can use a transistor behave like resistor. So we have a two type of resistor. We can use a fixed resistance for designing an analog circuit. We can use a MOSFET based resistor also, where they can be used, where we can't use the fixed resistor, where we use a MOSFET based resistor, we will discuss. So let's start with a resistor that you have a fixed resistance. Let you have a resistor and you are designing as a circuit by the fixed resistance. Let you are designing a simple inverter. This is an inverter also. You can say that common source amplifier also. I can say that inverter also. This is inverter also. Okay. This is an inverter also. We can design inverter by the CMOS only, not CMOS only. We can design by different way. This is one of that way you can design an inverter. Okay. So this is the resistor. You can use the fixed resistance. You can use a different type of resistor like a MOSFET base. So let's understand what is the meaning of the fixed resistance. Fixed resistance is basically is what happening. You have a voltage, you have a current, and if you make the graph of the resistor, it will be look like this. Voltage is increases, current is increases, that is a linear graph is happening. If you have this type of graph, that you can say that it will be act like a resistor. If any element is look like this, if any element have a property like this, so it will be act like a resistor. If you are interested in a MOSFET, I think you know about that ID versus VDS curve. That is a basic understanding of the MOSFET characteristics. ID versus VDS. That is the graph that you are designing ID versus VDS. Till overdrive voltage, let this is a overdrive voltage, it is behave like a resistor. MOSFET can work in a linear region, saturation region, subthreshold conduction region and cutoff region. So we can use a MOSFET as a resistor. That is the property. I am just saying that current and voltage have a characteristic. If any element have a property like this, it behave like a resistor. MOSFET is also behave like this property. If you are looking this part, that will be act like a resistor. So it is a resistor and we can. So I can say that the MOSFET can be work as cutoff in this region, can be a subthreshold, can be a linear or triode region, and fourth one is saturation region. So there is not any necessity to use a resistor, fixed resistance. Why it will be a problem? Why we are going for MOSFET based resistor? You know that VLSI is a monolithic. On a single chip you can design anything. By the silica only you can design everything. So what is the meaning? You can design a resistor, you can design a capacitor also by the help of MOSFET. Because if you are going for fixed resistance, it will take too much space. That is poly resistor. That will take too much space if you are going for a accuracy. But you can design a resistor by the help of MOSFET also. Of course, this MOSFET have some problem. You just think in this way, okay, you use one MOSFET and you are providing some voltage Vx and you are providing some voltage at Vy here. You can use this MOSFET as a resistor when this MOSFET is act like a linear region. And you know that what is R? R is directly proportional to 1 upon mu n CoX W by L. VGS minus VTH. I think you must have a basic knowledge of MOSFET. That's why I am discussing this part. If you are not good in MOSFET, we will discuss in a MOSFET part. But firstly, you can think in this way, just cover the upper part. Why we are going for fixed resistance? Why we are not designing a resistor by the help of MOSFET? We can design it. Yeah, we can. And by this resistance, you can eliminate your space. You can reduce your area. Simply you use the MOSFET and make that MOSFET in a linear region. Just supply that, and in this way that MOSFET work in a linear region, and you can follow this. And the MOSFET behave like a resistor. That is okay. But what is the problem? Of course, it is not that much good. It have a resistor have a property that R is 5K. That is okay. That is a fixed resistance. But not resistance is always fixed by this value. Why? Because there is a process variation, that is mu and COX. The mobility and oxide capacitance. Here the resistance is dependent on process. It depends on parameter, that is called W by L. Mu and COX is a process. W by L is your parameters. And depends on voltage also. So I can say that in a one line, voltage controlled resistor. Okay. So whenever you require a tunable resistor, whenever you require a controlled resistor, you can use a MOSFET based resistance. If you want a fixed resistance, the example we will discuss. Let I have a sensor. It can be anything. It can be ultrasonic, it can be a LDR, it can be IR, it can be anything. Okay. This is taking the signal and use a transducer, and it is converting that energy into electrical energy. And this potential is connected at this point. And you are giving some voltage here, and this MOSFET behave like a resistor on the dependent of the source or dependent on the sensor. If you are in BTech first year or second year, you use a LDR, light dependent resistor. So in a light dependent resistance, you have a two node and it have a some point over. And if you hand on that, the current is not flowing as per your programming. Okay, it depends on your programming. Of course, you have a 0 and 1. It depends on your programming. I'm just explaining in this way. Okay, if you have a hand on this, means that have a black region over that current is not flowing, and I am saying that will be behave like a higher resistance. If current is not flowing, means higher resistance is present. That means that LED will not glow, or that circuit is not working. And if you have a sensor and that sensor is here and there is no any black shadow, it have a good image of that light, so it have a current flow. I think we have a one more example, that is on a BTech, that we are designing a solar system. Okay, that solar system is fixed. Okay, and we cannot gather total energy. Why? Because sun is moving. Okay, so that is the way of the solar. So what we do? We can use a LDR resistor. That LDR sensor will sense that light intensity and it can rotate the solar. So what is happening there? It is happening by the resistance. Okay, it is happening by the resistance. You just control the resistance there. You are controlling the resistance. I am not using the fixed resistance. I am using a controlling resistance. By the controlling resistance, you are controlling the current. If you are controlling the current, you can control the DC motors. Are you getting my point? I think so. Okay, so by the resistance, you can control that current. So this is happening by the help of MOSFET. Yeah. You can control the resistor by the help of sensor. Okay, so this is the way you can. Okay, that is one of that way you can design a resistor by the help of MOSFET. Of course, MOSFET must be in linear region. then only you can follow the property of linear region. Of course, resistance have a property. Next, why we are going for fixed resistance? Let you have a fixed resistor and you have a one more resistor. Let this is R1 and this is R2 and it have a VDD. What is the voltage here? That Vx would be, if you know, that is basic formula, that is VDD into R2 upon R1 plus R2. That is a basic formula. What is happening here, dear? Why I am not using a tunable resistor or MOSFET based resistor? If they are fixed, we can find the fixed voltage because VDD is fixed. If you have a fixed VDD, you are finding the fixed value. Let just like a stabilizer, you are using a stabilizer, you are using a Zener diode here. In a Zener diode, you use a one resistor R1 and you are using R2. Before that, the voltage of Zener cut off, it have a voltage like V out is following V input with respect to V in into R2 upon R1 plus R2. But after that, it will be showing that Zener voltage. That is a stabilizer example. You can relate your topic as a 8th, 9th class only. This is just a very basic topics. So here we required. So if you are designing a reference circuit, that is called BGR or LDO, band gap reference circuit. These are the circuit, these are the analog circuit. That is the backbone of the analog circuit. Because if you are designing any circuit in your domain in an analog, you must require LDO, stabilized voltage. Because if you have a fluctuation in analog, of course it will be show the fluctuation in digital. So we find that stable voltage. So we can use a LDO, we can use a BGR. Here we are using that type of resistor, that is a fixed resistance. Whenever you require a tunable resistor, that is controlled by the MOSFET, that is controlled by the sensor, that is called tunable. So always remember one thing, in VLSI design, nothing is waste. You can use a fixed resistor, you can use a tunable resistor. It depends on your requirement. On the dependency of your requirement, you can use this type of resistor or this type of resistor. Okay, so this is the one example. So you can relate that where we are using analog. I am just thinking you are an analog circuit designer. That's why we are discussing in this way. Okay, you are analog circuit designer, you think in this way, okay, which time I am using this circuit and which time I am using this type of circuit. Wherever you require a control, you can. The overall analogy is this, you can design a resistance by the help of MOSFET also, you can use a fixed resistance also as the requirement on your circuit. Okay, let's talk about that the both resistor have own analogy. I am just writing in a one line, both resistor have a own analogy. Fixed resistor give accuracy. Of course, it will provide a fixed voltage. R1, R2 is present, is that Vx is equal to VDD into R2 upon R1 plus R2, that is basic potential divider. Or you have a potentiometer, you are using a potentiometer, you can find that perfect value. That is a fixed and that is give the best accuracy. But by the help of MOSFET, most resistors give control and flexibility. Where you want a control, where you want a controllability. What is the meaning of that silica? Why we are researching in electronics domain? Because you can control the current. Simple example is diode. Before the cut-in voltage, before the V gamma, the diode is behave like a open circuit, is behave like an insulator. After the cut-in voltage, diode is behave like a short circuit as an ideal diode. So you can analyze the current fluctuation in a semiconductor. This is that one part that MOSFET will give you the hint you can control and flexibility is present by the MOS resistor. but not always you use a MOS resistor. It depends on your application there. Okay. Let's talk about the capacitors. Of course, we can discuss capacitor also. How can we design a capacitor by the help of MOSFET? We have a MOSFET like this. What is the meaning of capacitor? Just like resistor, we discussed that current is increasing, voltage increasing, it is showing the linear path. Similarly, for a capacitor, what is the meaning of capacitor? You have a two conducting plates. In between two conducting plates, you have a dielectric. That is formed capacitor. So you have a two conducting plate. If you have a dielectric, it become a capacitor. Let's talk about this MOSFET. I am just change that flip that 90 degree. Okay. Okay. So what is happened? This is a one terminal. This is one terminal. This is the second terminal. This is the second terminal. And I am connecting all these drain source as like a ground, and I am writing that is Vx. Let this is Vx and this is ground. It look like a capacitor there. MOSFET become a capacitor, that is called MOSCAP. You can design a capacitor also by the help of MOSFET. And this is the way. And C is equal to epsilon A by D. D is a distance in between this. Is the area, how much area is covered. Epsilon is permittivity of this dielectric. So what is the benefit of that MOS capacitor? If you are using a physical capacitor like a MIM, metal insulator metal, it will take too much space, because if you are designing a nanofarad, it will take that much space. You require a W and L is very high. But if you can design by the help of MOSFET, you can make the layout in a proper way, and it will take less space as compared to any other capacitor. That's why we can use a capacitor. We can make the MOS capacitor also. By the help of MOSFET, you can design a capacitor also. And by this, let's think about it. Okay, how can you determine what is that value? I have one example for you. Let just solve it at your end. You have a capacitor and that value is C. How that ways you can determine the C value? Similarly, just think in this way. You have a resistor and that is R. What can you do to determine that resistor value? You just simply use what? You just simply use one voltage here, and you find that what is the current through a resistor, and you are using that simply V by I is equal to R. You can determine it. Yes or no? You are determining the value of resistor. I don't know what is that value. How can you determine? You just follow that voltage and find the current, and V is equal to I, basic Ohm's law, and V by I, that is R. Let's talk about capacitor. I have a capacitor. It can be designed by the physical capacitor or it can be designed by the MOSCAP. And that is very, very important topic in analog. Why? Because that parasitic capacitance introduced in layout, and we don't know what at that value. If you don't know what will the value, how can we reduce that value and how can we increase that value? So of course you must have a basic understanding. If you have only C, I have a basic example for you. Let you have a C. How can you determine? We have a lot of ways. We have a, I think 10 to 20 way. So you can determine this capacitance value. We will discuss. Okay, please comment on this. Okay, how can you determine the capacitor value? At least 2 to 3 ways you must explain. And that is very important question in interview. Let you have one capacitor, how can you determine this capacitance value? You can use anything. You have every element you have. You have a voltage source, you have a current source, you have a resistor, you have every type of waveform, you have a op amp, you have everything. You have a tool. Just determine it, what is that value. This is the one of the question for you. Please work on it and take the analogy. What is the good quality of the analog? That is a very basic topic, but you can confuse it here. So let's discuss how can you determine it. Okay, we will discuss in the next class how can you determine the capacitance value, and I will show you on the tool also. But firstly you will work on it. Just like simply I am using a resistor and find that current, just putting that voltage V and find that V by I is equal to R. Similarly you can here, but how it will be? Okay, just tell me. So you can design a resistor, you can design a capacitor from the MOSFETs. Let's talk about the inductor. So in an inductor, inductor does not behave like a MOSFET, does not behave like an inductor. Why? Because MOSFET does not have a coil. MOSFET does not store the magnetic field. MOSFET can store the electrical energy. How? This have a path. If have a positive, it have a negative, it have an electric field in between. It can store. But if you talk about the inductor, the MOSFET does not have any coil, does not have any space for the storing the magnetic field. So you can't design, MOSFET cannot behave like a inductor. That is a very good question for an interview. You can design a resistor from the MOSFET. You can design a capacitor from the MOSFET. But what about the inductor? MOSFET cannot behave. My word, please pick my word. MOSFET cannot behave like an inductor. But you can design an inductor from the MOSFET circuits. You can design. You can design. How you can design it? That is very basic example. You know about this circuit, that is called op amp. This is the Maharathi of analog. That is a mathematical operator. In terms of analog, I can say that this is a mathematical operator. You can add it, you can multiply it, you can differentiate it, you can use this circuit for a integration, summation, everything you can use by the help of op amp. That is, op amp is operational amplifier. That is a backbone of the analog circuit. You can design anything from this. So of course the MOSFET cannot behave like an inductor. That is okay. So क्या मतलब ये हुआ, we cannot design an inductor? Yes, we can design a inductor by the help of MOSFET circuits. What we'll do? We can design a circuit in this way of the op amp. So V become a X di by dt. You can operate the op amp in this way कि your V become a X di by dt. I am writing X di by dt, where X is what? Become an inductor. The relation of voltage and current in terms of inductor is V is equal to L di by dt. V is equal to L di by dt. So if you convert this circuit in the way, your V out become a X time of di by dt. That X become an inductor. That is one of that way. This is not the only one way. You can design a different way. But the only MOSFET cannot behave like an inductor because it does not have a turns. It does not have a property to store the magnetic field. That's why we cannot make it to behave like a MOSFET is behave like an inductor. If you are forming the inductor by the help of MOSFET, you require for a circuit. You require a proper circuit to design it. So that is one example. you have a op-amp, you can do in this way, you are using this op-amp in this way, that the output voltage become a X time of differentiation of current. If you design this type of circuit, so you can say that X is behave like an inductor. So this is the way, this is the beauty of that analog. So this is the beauty of the analog, where you can design a MOSFET as a resistor, MOSFET as a capacitor, MOSFET as an inductor. Okay, MOSFET as an inductor is not possible. So what we can do, we can in this way. So we have a different circuits. One of that circuit is by the help of op-amp. Okay, so just think in this way, okay, you have a resistor where we use a MOS based resistor, where we use a simple resistor, where we use a cap, and where we use a MOS cap. We don't use a MOSFET as a capacitor, so we can make the inductor by the help of op-amp, by the help of two MOSFETs. Okay, we have a lot of way to design an inductor. Okay, so that is the way you can. So these are the basic properties you must understand about the MOSFET. So let's talk about that very basic part of that sources. So till now we discuss, just revise it, till now we discuss from the beginning of that network and circuit. After the network and circuit, we discuss about the resistor, capacitor, inductor, and those effect in the layout. Okay, what is the meaning of routing? Routing is basically a connection in between 2 points. Okay, that's why you are using routing. And how you can route? You can, by the help of metal, you can route. You can use a different type of metal, metal 1, metal 2, metal 3, metal 4. What is the meaning of metal 1, metal 2, metal 3? That metal 1, metal 2, metal 3 is represented in the terms of width also, in terms of height also. When we discuss the layout, we will discuss metal 1, metal 2, metal 3, all are conductor. Why we are giving the different name? Because we are representing the from the substrate to that height, we are representing a different name, that is metal 1, metal 2, metal 3, and as per your increasing that metal numbers, as per the width will increases, as per the current carrying capability will increase. So if you have a metal 10 and if you have a metal 1, so whenever you require a high amount of current, so use a metal 10 for a current carrying capability. Just like for power routing, we are using a higher metals, metal 10, metal 9, metal 8, because it have a current carrying capability is very high. But if you have a signal traveling, if you require a signal routing, you can use a metal 3, metal 4, something like this. Metal 1, metal 2, and these are the basic metals. The very low metals are using for a base layers, for a base connection. You are using that. Okay, so just think in this way. Why? What is the meaning of routing? Why we have a different name of the metal 1, metal 2, metal 3? Just explore yourself there. And then we talk about resistor. Resistor will affect, if you increase the length, the resistance will increase. If you reduce that area, that resistance will increase, because R is equal to rho L upon A. Okay, what is happening by the help of resistance? If the resistance will increase, the delay will increase, because tau is equal to RC. And in a layout, you are not forcefully using a resistor. A metal will impose your resistor. So we discussed this part: resistor, capacitor, inductor. In an inductor, of course, the inductor is not present in an IC. We are not forcing that make an inductor, because inductor is like a lion. L for lion. L is not inductor. L is a lion. Okay, it can damage that different circuit because it have a magnetic field, and magnetic field can damage the another circuit also. So that's why that we are not using an inductor. And then we talk about, and today lecture is why we are using a fixed resistor, why we are using a tunable resistor. We can design a resistor by the help of MOSFET. We can design a simple resistor by the poly resistor. Poly resistor means you are designing by the poly layers, that is base layer, poly layers, because poly is just a high silica. doping concentration. Okay, we will discuss when we are talking about EDC. We have a lot of parts. Okay, but if you are systematically understand this concept, now you can analyze all these parts. Okay, so now we are going for sources. So we discuss all these parts of the resistor, capacitor, inductor, and the analog domain and a layout domain, everything we discuss. Let's talk about sources. So in this term we have a firstly, that is ideal voltage source. Ideal voltage source. Ideal voltage source means what? Of course we want a voltage source is ideal. हम लोग हमेशा चाहते हैं, we always want a ideal thing. We want ideal op amp, the gain is infinite, bandwidth is infinite, CMRR is infinite, everything is infinite, output impedance is low, of course, है ना? So we want ideal thing, that ideal diode for a V gamma is 0, before that it is 0, the current is 0, it will behave like an open circuit, after that it will be a behave like a conductor, everything. We are trying to make that ideal, but it is not possible, of course. So firstly, think about it, what is the meaning of ideal voltage source, then we will discuss about the practical voltage source. So we have a voltage source and we have one network. I am just writing the network or circuit, and we have a V. So if this is a ideal voltage, this ideal voltage will be same voltage present in the network. There is no any waste in a source resistor. There is no any internal resistance present in the ideal voltage source. If I am talking about the ideal voltage source, means this voltage will be same for a load. This will be not damaged. Just like that last example we discussed, that is IR drop. We have a 0.5 and we are using a metal rod and we use a one block here, and I am saying that okay, this have a drop is 0.2, it become a 0.3. What is that meaning? It have a drop here, dear. It have a drop. But for an ideal voltage source, I am saying that this source resistance is 0. There is no drop. It is a perfect voltage source that does not have a source resistance. Just think in this way, you have a battery, lithium ion battery, okay, in a EV, and of course you will tie it with a nut bolt, or you are connecting by the tap or anything by the connection, and you take the current from by the help of wires and use for energy, for an electric vehicle, for anything, for a light, for engine, for anything. Okay, you are using. Ideally you want there is no waste. The battery have a 9 volt, let the battery have a 9 volt, it will be same for a load. But it is not happening. Practically it is not done. Of course it have a drop. It have a drop by the, if you have a bolt na, if you have a car na, if you have a car, in a car you have a bolt and you are tightening this, of course it have a drop. It have a resistance. It have a carbon. So it will be not 9, it will be 8 point something. Okay, so ideally we think that it will provide a 9 volt, but it will not. So for an ideal voltage source, we are designing that chemical engineers or battery engineers or these type of solid state engineers trying always to make that RS is near about 0, but it will not. It have some value, 1 ohm, 10 ohm, 13 ohm, 15 ohm, 1 kilo ohm, it will be. So that the ideal voltage source means what? The voltage will be same for load also. There is the internal resistance is 0. The internal resistance RS, let this is Vs, the RS is the internal resistance of the voltage source is 0. And what is happening of the current? If you have an ideal voltage source and you have a load RL, so the voltage will be same. Why? Because V out is same as V, and the current, it depends on what? It depends on RL. I is equal to V by RL. The current can be increased, can be decreased, it depends on the load. So I can say that if you have an ideal voltage source, it can have any amount of current. That it can pass any amount of current through it, but it will provide a constant voltage or ideal voltage towards load. That is called ideal voltage source. In a characteristic terms, we can use in the characteristic way. If you are represent in the terms of graph V versus I, the voltage will be constant, current can be anything. Current is dependent on the load. That is the value of ideal voltage source. The voltage will not have a potential divide by the help of resistance, that Rs is 0, so that internal resistance is 0, so internal voltage drop is 0, so the same voltage will be present through a load. That is called ideal voltage source. Whenever we solve the network, we always assume that this is an ideal voltage source. We always assume that we always solve every network. You solve that superposition theorem or Norton or KCL, KVL, any question you are solving, you always think in this way, this is an ideal voltage source. You never think that this is a practical voltage source. There is no any internal resistance. And the internal resistance is always present in series. Always present in series, not in parallel, because in a parallel the voltage is same. In parallel voltage is same, in series current is same. In a voltage source, that voltage drop is happening in a series. So I can say that in an ideal voltage source, current can be anything. Voltage will be fixed. That V out is equal to V. That is called ideal voltage source. Let's talk about ideal current source. In an ideal current source, you have a current source and you have a resistance, that is RL. The current is divided in parallel. It will be same in series. If I am talking about ideal current source, that means I am thinking in this way, the load have a maximum current. Maximum current means it is I, so it will be I. So across the load, through the load, you have a current is IL is same as your I. The load current is equal to the source current. There is no any drop inside the internal resistance. So if I am saying that there is no any drop in an internal resistance of the current source, that means this is look like an open circuit. There is no any internal resistance. The pure current is going towards the load only. So if I am saying that this is Rs, the source resistance of the ideal current source, that should be infinite. For ideal current source, the internal resistance is infinite, so that you find that the load current will be equal to the source current. In an ideal voltage source, the load voltage is same your source voltage, means the internal resistance is 0, then only it have a no drop. And that is very important question for an interview. Once you go for the interview, they will talk about ideal voltage source and ideal current source. How? Okay, let's discuss one question of that ST microelectronics. ST microelectronics asked one student, okay, you have a ID, you have a VDS, make a graph of ID versus VDS of the MOSFET, explain that in this way. Okay, student, write in this way. Okay, sir, this is the graph of ID versus VDS, and this is the overdrive voltage, where after the overdrive voltage the current is constant. So that interviewer asks in this way, okay, that current will be constant, so it will be behave like an ideal current source. Of course, if you are talking about the ideal MOSFET, the characteristic like this, because the current is constant, the voltage can be anything. Ideal current source, what is the graph? That is V and that is I. The voltage, it depends on what? VL is equal to I into RL. Voltage can be anything on the basis of the load resistance. If load resistance is high, voltage will be high. That depends on the load impedance. Voltage will increase as per the load, because the current is constant. One of that is parameter is constant. The load resistance can vary. So voltage can be anything. So I can say that by this, that current is constant throughout the load, but the voltage can be anything. That will be a source current. Load current is equal to a source current, and voltage, the load voltage can be anything. If you are explaining in this way to this graph, after this graph there, after just moving this graph, after the overdrive voltage, it is act like an ideal current source or not? That's why MOSFET is behave like a constant current source. We are saying that the MOSFET, we can design a MOSFET as a current source. That's why you are writing that MOSFET is a voltage controlled current source. Because after overdrive voltage, the current become constant. And that is look like that voltage can be anything, that current is constant, is a constant current source. Okay. So if you make the MOSFET in a saturation region, that ideally, I am not saying practically, this is an ideal. So of course this will be also ideal. It is not possible by the practical MOSFET. If you are writing the practical MOSFET, what will be happen? The practical MOSFET is looking like this. It have a graph like this, but it will be like, there have a slope. It will be not constant. That is happening by the channel length modulation. Okay. It will be not a constant current. It have a some current slope. Okay, so this is the way you can make an interest of basic topic. These are the very basic topic, but everything is related as a fundamental there. If you know the ideal current source, but you don't know about the MOSFET characteristic, or you cannot relate properly, that is, you are not good in fundamental there. You can relate in this way. Okay, this is that happening. Okay, this is also happening. I am just saying here that voltage can be anything. Current is constant. In an ideal MOSFET, I am also thinking after the overdrive voltage behave like ideal current source. That's why MOSFET is behave like a voltage controlled current source. Or you can analyze that there. Okay, so just work on it. Okay, that is the very basic fundamental. And of course that if and how you can prove it that resistance is infinite in MOSFET? That's simple way. In ideal MOSFET, what is the current? Current is constant. What is the slope? The slope is 0. Dou ID by dou VDS is 0. If dou ID by dou VDS is 0, so dou VDS upon dou ID means V by I is a resistance, not I by V. I by V is conductance. V by I is a resistance. So dou ID by dou VDS is slope is 0. So what about the meaning of dou VDS upon dou ID there? It is 1 by 0, na? It will be an infinite here. So everything is proven here that ideal current source have an internal resistance is infinite. As a understanding of basic fundamental, you use these basic fundamental in a MOSFET operation. It is looking like this. This is after overdrive voltage, the current is constant, the slope is 0, that resistance is infinite. Okay, and if you talk about the practical MOSFET, if you are talking about the practical MOSFET, it is not like this. It have some slope. So dou ID by dou VDS is not 0. It will be some value. Of course, it will be a small value. And if it is a small value, the dou VDS upon dou ID, of course, I have a high value. High value and infinite have a difference there. High can be 10K, 100K, something. Infinite means infinite is not a proper, infinite not a physical value. Infinite means I am just thinking in an idea, the current is 0. Current is not flowing through this resistance, RS. But if you talk about the practical MOSFET, that have some current and that have some slope. So of course this resistance, it would be not infinite, it would be have. So similarly, once you talk about the practical current source, you have a RS, you have some value of RS. So of course you have a drop here. So this load resistance does not have a current is IL is not equal to I. IL is have some difference because that have some resistance current. Okay, let's discuss about the practical current source first. Practical current source. Practical current source means you have a current source, but this current source does not that have an internal impedance. It have some drop through an internal resistance. That means it have some source resistance, that is RS, and it have a RL. So if this is IS, so current have divide here in RS and RL there. So I am saying that this is IX. So that IL is not I, it will be I minus IX. That is a basic thing. If it is 5, if it is 2, of course is 5 minus 2 is 3 ampere. Okay. So this is the practical current source. Similarly, I represent in this graph in a MOSFET, this slope is represented dou ID by dou VDS is not 0. It have some slope, it have some value. So of course it have some current. So RS is not infinite. RS is not have an infinite value. It have some value where that current is flowing. That means the load current is not equal to the source current. The load current have a less than that value. It can be I minus IX. So that is the way you can analyze that MOSFET ideal current source and MOSFET based circuit. Okay. Just analyze these concepts here properly. Just think on very small topics. Just work on the basic topic. Then only you can design analog circuit. Analog circuit not required a rocket science. It required a basic requirement of the current, voltage, resistor, inductor, diode, basic property. If you can understand how the current is flowing from this path to this path, how can we increase this amount of current, how can we decrease, how can we determine the voltage, you can analyze anything in analog circuit. Analog circuit is purely mathematics. It is purely mathematics. Once we go for the KCL and KVL, that one line have a network, that entering current is equal to leaving current. That is a one line. After this, you will solve the mathematics. If you are good in mathematics, then only you can solve that answer and you can find the answer. But in a one line, you have a one answer, that entering current is equal to leaving current. Similarly, if you are using KVL, that algebraic sum of voltage in a loop is equal to 0. That is a one line. After this, you are using all these formula, basic mathematics, and you solve it, okay, and then find out that voltage or current. So everywhere you will find that basic. If you know that basic thing, you can. That is the practical current source. This is a practical current source. Is it okay? So this is the way that is practical current source. Let's talk about practical voltage source. In a practical voltage source means what? You have a voltage. You have a voltage, but the resistance, the source resistance is not 0. It have a some value. So what is that meaning? Of course, this voltage, this load voltage is not V. This voltage, load voltage is not V. It is V into RL upon RS plus RL. Means the voltage is decreases. The load voltage is not equal to the source voltage. The load voltage is less than the source voltage. That is the way you can understand. This is the practical voltage source. So in a practical voltage source, this is voltage and this is current. So in previously it is ideal. It was ideal, but now it will be decreasing by the help of RS. As per RS will increases, as per the load voltage will decreases. Because RS is denominator. If RS is increases, your load voltage decreases. So it is decreasing due to RS. RS is increases, it will decreases. Similarly, in current source, in a current source, the current will, in a practical current source, an ideal current source is constant, but the practical current source will decreases. Why? As per RS will going down, will be down. RS is not infinite, RS is going down, have a lesser value. That more current will be passed toward the source resistance. If RS is down, RS have a low value, so that most of the current will be passed towards this. As means that load current is low. So if you talk about the load current with respect of V, so ideally it was like this. Ideally it would be like this, that constant current whenever that voltage can be anything. But now that as RS is decreasing, as much amount of current is passing through RS. If RS is decreasing, as much good current will pass through this. So basically what will happen? It is decreasing there. Why this is happening? Because RS is decreasing. If RS is decreasing, the current will decrease. Similarly, if RS is increasing, that voltage is decreasing. That is the basic funda of practical voltage source. An ideal voltage source and ideal current source, practical voltage source and practical current source. Next class we will discuss about the dependent source, voltage control voltage source, voltage control current source, current control voltage source, current control current source. We have a 4 dependent source, voltage control current source, current control voltage source. We have a 4 types of dependency. Why we studied about the dependent source? We discussed about that is practical source and something. Okay, so we have an independent source, we have a dependent source, both source we have. We have a two type of sources there, independent source and dependent source. What will the difference? We will discuss. Today is too much. Okay, if you studies this topic, now it have a lot of things is available for your study. The today's topic is for at least you require a 12 to 14 hours to revise all these things, because this is just like a point there. I am just discussing these point. You require this routing there. Then only you can make a diamond. If you want to become a diamond, of course, you will make a route. I am just giving a point because the time have a limit. We have a permit of time. We have a limit. I am just give the whole point. I am just circulate this point. Just analyze these points, and then you can make a diamond. Okay. I think it is enough for today. So tomorrow, or I think 26, we will discuss about the independent source and the dependent source. And I will request to Vaibhav sir, he will provide a quiz. Okay, so we will provide a quiz also, so you can more analyze. The quiz is assigning in this way that you will face the one line question in an interview. So you have a 5 to 10 quizzes. Okay, 5 to 10 number of questions is present. So you can solve in an objective way. And every questions of the quiz, you can elaborate every option. Don't solve only one question in a quiz. If you have a quiz and you have a 4 option, elaborate all 4 points. Then you can improve your learning. So for today, thank you so much everyone. Bye bye. Take care.